name is Dr. Karen Bolter. I'm a climate scientist for Deltares USA. I'm located in South Florida. I'm sorry I couldn't be in New Orleans with everyone for this conference, but I'm really thankful to be on this amazing panel talking about green infrastructure and nature-based solutions, specifically a tool that was developed by Deltares, the Climate Resilient City tool. It provides logistics for green infrastructure, blue-green solutions. What it does is it compares a variety of options for resilient design and provides quantities and metrics so that you can rank those different options, measures for a specific study area. So it's a mapping tool. It was recently customized for New Orleans, and it really helps for a broader solution for flooding, all types of compound flooding, whether it's riverine, coastal, stormwater, because in the natural solution realm, we're really trying to create more retention and detention for stormwater, for surge, and for a range of events from chronic to acute events. So I'll start by just talking a little bit about myself and Deltares and what we do. So I mentioned I'm in South Florida. I have degrees in environmental engineering, environmental science, and my PhD is in science, really just GIS analysis of sea level rise and climate change risk on all types of data sets and issues. So you could see that in the photo there's a picture of me with my 4-month-old baby, and that was actually taken just yesterday. We were at a King Tide event. So a lot of what I do is like outreach, trying to I helped to organize the event, and I was a speaker showing in Hollywood, Florida, that this is one of the highest tides of the year. And so we knew that there would be 2 feet of water in the road. So we had like a march with the mayor, and it was really cool. So that's just a little about me. And so I'm really excited. I've been working with Deltares for about a year now and learning all about the amazing work that's done for ecosystem-based adaptation in urban areas for climate resilience and how we can optimize ecosystem functions and services. So we have a lot of different tools and data sets for nature-based solutions. One of our tools, the Community Flood Resilience System, is a DHS project. So that's the screenshot in the bottom right. That's a project that we started in Charleston, but we're expanding it with DHS so that across the United States, anyone can use this tool, not just to look at what their vulnerability to climate change and sea level rises, but also solutions. So we actually, in the tool, you can see there was a mitigation like a seawall or a pump, and you can see before and after that mitigation for any type of storm, whether it's a synthetic or previous storm that you tweaked, you can see what the damages were to buildings, to roads, people affected. There's an equity component. So that's just an example of one of our tools. All of our tools are open source, freely available. We're a nonprofit. So it's a really great company, and I'd love to connect more and partner from people attending. So let's get into what is that ecosystem-based adaptation to climate change. I mean, all of these issues that we have related to flooding, heat stress, and drought, we want to have solutions that are flexible, adaptable, that we can really reap co-benefits from to maximize resilience. And like health is an important co-benefit, walkability, economic development. So, all of these different green infrastructure options are so important because they're not just protecting us from flooding, but they also prevent water pollution. They can even tackle soil and groundwater pollution. There's rainwater harvesting for, not just for stormwater, but surface water, and it can be used for food production. So there's a lot of amazing stuff that can be done. It really leads to this context for adaptation, because really the problem, like for me in South Florida, we have this, we call it a culture of seawalls, where everything is, hardened and raised and it's very gray. It's just kind of the way the policy and the land use and the culture is set up. And a lot of cities are having these issues where they've been designed for current or past conditions, and then there's increasing physical risks because of climate change and sea level rise. There's also increasing exposure to those risks because of increasing populations and urbanization. And we have to work with what's already there in these cities. So we're retrofitting. So it's really important kind of getting to know the urban ecosystem and look at different adaptation measures and how they work in a specific area. And more, green infrastructure is becoming the preferred solution. I've worked with so many communities that just really are strongly stating that preference and fighting against the different type of hardening projects that are being proposed. So it's prioritized at the local level, and the federal government is starting to prioritize it as well. Like for the FEMA applications for the brick projects, green infrastructure is a criteria that carries a lot of weight. So it's really important to create this context for adaptation. So let's talk a little bit about the tool. The tool is really designed as a tool to be used, in a group setting with a lot of stakeholders, planners, designers, engineers, so that they can explore different measures and make decisions in a collaborative design process to find effective solutions with co-benefits. So just an overview of the tool, it's a very simple website. You could just go to crctool.com. It has 62 different green infrastructure adaptation measures, from green roofs, bioswales, porous pavement. It's site specific, so you can see in the screenshot here, I zoomed into the exact hotel where the conference is and made a little polygon, and then it pulls up a list of measures that would be appropriate here and kind of ranks them immediately based on their effectiveness. And in terms of their effectiveness, the metrics relate to storage capacity, reducing runoff, heat stress reduction, groundwater recharge, water quality, and you can not only look at one measure, but you can look at them combined. So it's a really amazing tool. And if you're in a group setting, you can be using a touch screen, projected to just explore different adaptation interventions and situate them into your specific project area and immediately get an estimate of what their effectiveness is and what their costs are. So it's pretty amazing for those things. So let's look a little at those measures and what they mean. So your goals for adaptation can be a range of them. You don't have to select one. In most cases, you can select all of them. But it could be flooding, drought, heat stress, water quality. And so each of these has different calculation methods. So at the end of the presentation, there's a user manual and all of the metadata on how this is all compiled. So there are a range of performance indicators, and they can be turned on and off. So here's what it looks like, the user interface. So on the left, there's a tab with the overview of adaptation measures, and it has buttons for additional information. So you draw the measure on the map. So here, actually, this is what I did for the area around the conference. So I was able to draw this this polygon, and then I say add measure. And for each of the measures, you could see that here, this for water square, there's 64.8% applicability score based on the project properties. So if I choose it, it's going to tell me even more information about it. So it's a really cool interface. So that middle pane, once we've drawn our polygon, it shows the project area, and on the right, that's the overview tab of the effectiveness of adaptation measures, including storage capacity, return time of flood event, evapotranspiration, groundwater recharge, water quality, and also construction and maintenance costs, which is amazing to get those types of estimates for the performance indicators. So there's a lot of different green benefits that are shown. You can see on the right here, like there's the water roof, adding trees to the streetscape, and then you can actually see there's a legend for stormwater flooding before and after the measures and how it changes. So really quantitative tool with a lot of solutions. Here's an example in the Utrecht Center where in 2018 the tool was implemented, and you can see that we have these beautiful hybrid green infrastructure buildings. And I mentioned the tool was also implemented in New Orleans, and here's the references so you can look at the website for the tool and see more videos about the project in New Orleans. You can read some of our peer-reviewed papers on it, and you can also see our documentation and manual. So that's it for the presentation. Here is my contact information, and yeah, please reach out. Thank you so much.